Assalamualaikum and good day. So in this video, I'm supposed to show you on how to use Excel in carrying out the uh, analytical solution for the position analysis. Alright, so we are going to visit again the truck bed problem. So in this case, of course, we're going to retract the hydraulic cylinder by 0.15 meter. And what will be the angular displacement of the truck bed, right? Then from here, we need to draw the kinematic diagram. And from the kinematic diagram, as we discussed in the class, we already got all the equations which is required for the analysis. So in this case, we can see that all the solution depends on the first parameter, which is the length of AE, right? So let's calculate using Excel on the angle, the original angle of the truck bed. So in this case, we start, okay, this is the Excel. Let's say we made a very simple one. First, we have AE. Then we have angle EBA. Then angle EBF. Then angle FBA. So the rest we will continue once we are going to the next slide. So in this case, EA is 1400. So for the angle EBA, as the angle here, as the equation here shows that we are using cosine equation. So for that, we have to solve here, which is equal. Okay, now Excel normally operates or basically calculate using radian. So even if you solve a solution for a cost, at cost, it will spit out or basically produce a result in radian. So since we need it to be in degrees, we have to first there's a function that we can actually convert it into degrees. So it's going to be, in this case, it will be degrees bracket then arc cos, or simply arc cos here. So we have two parts on the numerical the top and the bottom part. So we put the top part first. So in this case, 1400 square. So you use that sign to denote as square, plus 300 square, then minus. So in this case, it's also 1400, but this one they represent this length, and this length is basically represented by this. So as we are here, so basically we just click on here, square, close bracket, divide by, so in this case, 2 times 1400 times 300, close, and we close again the bracket for our cos, and close again for the degrees. So basically we get 83.84, so basically approximate 83.8 degrees here. So now we want to calculate EBF. Again, we are using the cosine equation, cosine rule equation. So equals to degrees bracket cos bracket, again top part, which is 420 square plus 300 square. So in this case, basically EBF does not change. It is a constant, but okay, anyway, we just can continue calculating it. Then minus 300 square divide by 2 times 420 times 300, right? Close bracket, close bracket. Hold on a second. Okay, there's a mistake here. There's a mistake here. Yes. uh, uh, then another bracket for the degree part. Is it? Yes. So it's 45 points, in this case 45.57, or if we round out it becomes 45.6. Anyway, we just maintain it as 45.57. So FBA, okay, let's, angle FBA is basically equals to EBA minus EBF. So in this case, this is equal to EBA minus EBF. So we got 38.27, or basically 38.3. So move on to the next slide. We need to find FBC. All right. FBC. Then we need to find L FC. Right. This actually is, say this is a subscript LFC, just like here. And then we need to find FCB, then angle of FCG, then finally angle of GCB. All right, this is a trap bet. So FCB is basically equals to 180 minus FBA. Okay, that means 180 minus FBA, which is 141.7. Right. So the length of the LFC now, so it's basically a square root of the rest of the thing. So LFC equals to SQRT square root of in this case, okay, we'll put the bracket 420 square plus 650 square minus 2 times 420 times 650, okay, times cos. Okay, now this should be in radians actually, right? So we have to put radians. Oh, sorry. Radians, and we put the angle here 141.7, which is this one, and we close it again, right? Then we close the square root part. Oh, sorry. Okay. So basically it's 1013.67, which is 0.7. Okay, same thing. Okay, sorry, this one. Then we want to find the angle for FCB. So sine FCB is equal to that. So FCB is equal to a sine of 420. Let's make it into two parts. 420 times sine. Okay, we have to convert again radians of 141.7. Okay, close again, divide by this length FC, close. So it's basically, oh sorry, we have to put degrees here, sorry. So you got 14.87. Then for FCG, the angle, Okay, we just continue again, which is now we are looking for FCG. So in this case, we are using the cosine rule. So FCG equals to, of course, we need to convert degrees, right? And our cos. So it's a bit tedious, but then yeah, once we do it once, we can actually get a different answer later on. Or we can just change the angle and then we get a different answer. It should be no problem there. All right, our cos 1013. So in this case, we use this one, square plus 850 square minus 350 square. Okay, this is supposed, oh, sorry. This is something wrong. Okay, of course, a mistake. Okay, sorry. Then we divide by 2 times, put the length here, 1013 times 850. Get another one. Okay, so we get 19.18, which is basically 19.2. So the angle GCB is basically equals to FCB plus FCG. Yeah, now we got it, which is 34.1 basically. So let's say now, once we have this, we can basically change the value that we like. For example, now you're supposed to shorten it by 0.15 meter. So in this case, it will change to 1250. Everything will be updated and you got it 20.1. So let's check again at this part. Yes, 20.1. So it's very, very easy, except that you must be right when you are basically entering the formulas. If you commit a mistake here, then the rest of it will be a lot of mistakes. Just an error. Okay, I think that's all for today on using. Next, I'll be showing you how to create multiple input and multiple output for the angles, and from there we can actually see, we can create the displacement diagram. Okay, thank you very much. Assalamualaikum. Good day for everyone. Bye.